Welcome to Basic Electronics series. Today we will learning about Bipolar Junction Transistor Fundamentals. So here is the agenda: BJT, construction, operation, modes, types of BJT, bipolar transistor configurations, functions and applications. So this is the introduction. So it is a semiconductor device used for amplification and switching. So it mainly consists of 3 terminal and it consists of 2 PN junctions that are formed by sandwiching either P-type or N-type semiconductors between 2 P-type semiconductors. So it is used to transfer input signal through the circuit having lower to higher resistance. So this is PNP and this is the NPN transistor. The difference between PNP and NPN transistor is that the arrow mark at the emitter end. So here you see the arrow in the PNP transistor is mentioned as moving from the emitter to base. Whereas in the NPN transistor, so it's moving from the base to emitter. So the direction of the arrow represents the current flow in the transistor. In PNP, the current will be flowing from the emitter to base, and in NPN, current flowing from base to emitter. So the construction of BJT. The combination of PN junctions or built a BJT. So that is, a BJT is made up of P and N type semiconductors. The 2 junction divide the 3 semiconductors of a BJT, these are the terminals or layers: base, collector and emitter. The emitter and collector part of the transistor are placed on each side of the base. So there is emitter base junction and collector base junction. Here you can see the diagram. So this is the emitter, the outermost layer of the transistor. So it is heavily doped with N-type or P-type semiconductor material. So P-type material is often employed to produce the emitter of a PNP transistor. So whereas N-type material is mostly utilized for creating the emitter of a NPN transistor. And this is collector and one more is the base. This is the base region. Here we having base. So the intermediate layer is called the base. So it forms a narrow zone between the emitter and collector and slightly doped. It is made up of different material than the emitter. A NPN transistor base is P-type. In PNP transistor base is of N-type. And this is the collector. This is the inner layer. And it is modest doping level. So the type of semiconductor used in the designing is the same as that of emitter. In NPN transistor, collector is formed from N-type material, whereas PNP transistor, collector is made up of P-type material. And here you can see emitter base junction. So the emitter base junction is nothing but it is the junction that is formed between emitter and base. So during normal operation, the junction is forward biased. But this collector base junction, so it is the junction between collector and base. So during normal operation, this is reverse biased. And next is the operation of a BJT. So the NPN bipolar junction transistor has the majority of charge carriers as electrons. But in PNP, we having holes. The current flow is not the result of majority charge carriers. Despite their quantity, the current flow is due to minority charge carriers in a BJT. So that is why are also named as minority minority carrier devices. In emitter based junction is always forward biased. I already said here in the previous topic. The collector based junction is reverse biased. So the emitter current, we having formula the base current plus the collector current. If we consider the base current to be very small in actual measurement, then we can say it as, if it is small means emitter current is equals to the collector current. So this is the operation of BJT. So the working principle of both NPN and PNP transistor is almost the same. Both of them differ in the conduction of current through charge carriers based on the majority and minority of charge carriers. So it consists of three regions: active region, saturation region and cutoff region. So in active region, the transistor is on in this region. And this is collector, emitter and base. So when collector base junction is reverse biased while the emitter base junction is forward biased, the BJT works in the active area. So as a result, BJT is used as an amplifier. So the collector current is proportional to and controlled by this base current, and relatively insensitive to VCE. So in the region collector current, so IC is equals to beta of IB. But in saturation region, so it will arise when collector base junction and emitter base junction, this and this both are forward biased. So that time transistor will on. The collector current varies very little with a change in the base current in the saturation region. So here VCE is very small, a few tenths of a volt. The collector current is strongly dependent on VCE. Unlike in the active region, it is desirable to operate transistor switches in or near the saturation region when they are on state. So here IC means I of, so IC is nothing but collector current, so that is equals to the saturation current of saturation, or we can say I of saturation. And one more region is cutoff region, right? So because of the emitter and collector junctions both are reverse biased, so the BJT is off in this condition and very small amount of currents flow from the collector to the emitter. So there is no current between the emitter and the collector. So this is about the modes of region. So types of BJT, one is the NPN bipolar junction transistor. So in NPN transistor, a p-type material is placed between two n-type materials. So the first n-type region is called emitter. So this is the emitter. So this is the n-type region, and p-type region is base, and one more n-type region is collector. The emitter base junction, so this one, is forward biased, and this is the collector base junction is reverse biased. So we need 0.7 voltage for silicon transistor and 0.3 voltage for germanium transistor. It must be applied. So because of forward bias, many free electrons move from the emitter to base. This flow of electrons forms the emitter current. So remember, conventional current direction is opposite to the electron flow, isn't it? So some electrons combine with holes in the base. So the recombination forms the base current. But the base is very thin, lightly doped, so only a few electrons recombine. And here most electrons do not combine in the base. They move forward to here, means collector, due to reverse bias. So this movement forms the collector current. So there is also a very small current due to heat generated charge carriers. So this is called the reverse saturation current. So how to remember this? Emitter sends electron to this here, right? Base controls them and collector collects most electron. This is how NPN transistor works as an amplifier or switch. And next is the PNP transistor. So this one. So it is little same, okay. In PNP first type, so this emitter is there, right? Sorry, here emitter. So this is P type and this is N type, that is base, and collector is P type. So emitter base junction is forward biased here and collector base junction is reverse biased. Here also for silicon 0.7 volt is applied and for germanium 0.3 voltage must be applied. Because of the forward bias, holes move from the emitter to base. Here the flow forms the emitter current. So here hole flow direction is equals to the conventional current direction, isn't it? See here direction is same, but in the previous session direction is different. So some holes combine with the electrons in the base. This forms the base current. The base is very thin, lightly doped, and so few holes recombine. Next, most holes pass through the base, reach the collector due to reverse bias. So here it will form the collector current. A very small current also exists. So that is due to the heat generated charge carriers. So this is called the reverse saturation current. So how to remember this process? When emitter send holes, base controls them and collector collect most holes. So PNP transistor works as an amplifier as well as switch. So this is about the PNP. And next is the bipolar transistor configuration. So that is nothing but common base configuration. So in common base configuration, the base of transistor is grounded in common base characteristics with the emitter acting as a input and collector act as a output. So the emitter base junction is biased forward, means this junction, emitter and base junction is biased forward, whereas the junction between collector and the base is reverse biased. Low voltage gain but high current gain is offered by the CB. CB means collector and base arrangement. So it is frequently employed in impedance matching. It reverses the output signal phase with respect to the input and frequently utilized as a buffer between circuits with high and low impedance. And in high frequency application like RF amplifiers, we can use the common base configurations. So this is the characteristic curves. So there are two important characteristics of a transistor. One is the input characteristics. The curve drawn between emitter current IE and the emitter base voltage means VEB for a given value of collector base voltage is known as the input characteristics. So input characteristics of CB delta VCB at constant. Here you can see VCB is 10 volt and VCB is 0 volt, right? So how to find the Rin? So here we have a formula delta VBE divided by delta IE. So I is nothing but the emitter current and VB is nothing but the emitter base voltage. By solving this graph, you will find the values of delta IE and delta VBE. So this is the output characteristics. The curve drawn between the collector current means IC and the collector base voltage VCS. For a given value of the emitter current is known as the output characteristics. So R out means delta VCB by delta IB. To find the value of this, you need to solve this graph and you will get these values. Next is the common emitter configuration. So here emitter of transistor is grounded in common emitter configuration, right? So here emitter is grounded, means common it is. The base serves as the input here and the collector serves as the output. The CE configuration is like the CB configuration. It has forward biased BE junction and reverse biased CB junction. The voltages of CB and CE configuration are related by VCE equals to VCB plus VBE or VCB equals to VCE plus minus VBE, means this VCE nothing but voltage between the collector and emitter. So that is equals to voltage between the collector and base plus voltage between the collector and base and emitter. So that is VCE. But VCB means voltage between the base and collector. So this and this is, how to remember this? I will tell simple. So okay, VCE means emitter and collector. Voltage between these, how to do means VCB plus VBE. Okay, this plus VCB plus VBE. But to find VCB means to find the voltage between this, what to do means first we need to find VCE minus VBE minus this, then you will get the VCB. I hope you get it. The emitter current is given by, emitter current is the sum of base current and the collector current. A C design offers a modest current gain together with a strong voltage gain. So it is frequently employed in voltage amplification. Okay. So in a phase relationship, so it flips the phase of input signal in relation to the output. So typically used in general purpose amplification, so audio amplifiers, RF amplifiers. So here it is the characteristics, input characteristics. So it refers to the curve between the IB means base current and base emitter voltage for a particular collector emitter voltage value. So this is the input characteristics and this is the output characteristics. So to find this, we have to do graph between the IE and VCE. IE means emitter current and this is VCE means collector emitter voltage. And next is the common collector configuration. So here, so common collector configuration, in the common collector, the collector of a transistor is grounded here. So the collector of a transistor is grounded, then the base turns as an input, right? So this is input and emitter is the output. So one voltage gain but a significant current gain is achieved with the CC setup. It serves mostly as a buffer. Buffer means what is the input you will give, that only the output. So phase relationship preserves the identical phase between the signal received and sent. It includes impedance transformation, impedance buffering and voltage flowing to match impedance between the circuits. So this is the characteristics curve. So input characteristics. To determine the input characteristics, VC is kept at the suitable fixed value. So this is VBC and this is IB, the base collector voltage and base current. VBC is increased in equal steps and corresponding increase in IB is noted. So we need to find here input characteristics, and VC is fixed value here. And next is the output characteristics. The curve drawn between the emitter current and the collector emitter voltage for a given value of current is known as the output characteristics. And the function of BJT, we used it in amplification, switching and signal modulation. So the junction bipolar transistor is crucial for boosting electrical signals in devices. So we will use it in audio amplifiers because they magnify signals by regulating a greater current flow between the collector and emitter based on lesser input current at the base. And we also used it in switching. So it acts as the electron switches. They regulate the current flow between the emitter and collector. A key element of a basic logic gates and digital circuits, the BJT functions acts as a switch by applying a signal to its base, permitting or limiting the flow of current. Next we can use it in signal modulation. The BJT are employed in modulation circuits to change the carrier signal properties. So these transistors are essential components information transmission communication system. Why? Because they may change in signal characteristics like amplitude, frequency or phase by altering the base current. So this is about the functions of BJT. And next is the applications of BJT. So it is used as amplifier, switch, oscillator, and it is also used in the logic circuits, clipping circuits, demodulator, and used as a detector, temperature sensors. That's all about the BJT fundamentals. For more videos, please watch the upcoming classes. Thank you all.